integration of sine and cosine is backward integration, or it's backward differentiation of sine and cosine. And that's actually just the same trick. You have just to go in the other direction. So I just show you the trick. This is the trick. So you have to learn by heart. You should learn by heart, I think, this box, this square, right? Sine. But this actually, this differentiation. So when you differentiate and you have sine, then it becomes cosine. When you differentiate cosine, then it becomes minus sine. When you differentiate minus sine, it becomes minus cosine. And again, when you differentiate minus cosine, then you end up at the beginning where we started with sine. And when you integrate, now you just go the other way around. You start with sine, and so you would go this way with differentiation, but now we go this way with integration. And when we want to integrate this, of course, then we go again in this direction. It's basically the same as differentiation, but the trick is not to think that it's difficult, but just to learn this by heart. And remember, this is differentiation. Integration is the other way around. You just have to inverse the arrows. So it's not really complicated. You just need to know by heart this square. This is how it works. I will show you an example in a second, and I will also prove it with those nice wave functions. How to integrate sine and cosine? Actually, quite easy. You just have to remember the famous rectangle, which is the following. So concerning the derivation, it works like the following. You have sine differentiated is cosine. Cosine differentiated is minus sine. Minus sine differentiated is minus cosine. And minus cosine differentiated is again sine. So you just have to remember this rectangle, and then you can solve all these exercises with differentiation and integration of sine and cosine quite easy and very fast. And this is important for exams. So I would suggest just to learn this rectangle by heart. Quite easy. But what happens now in an exam if you forget about the rectangle? You think, oh damn, I forgot about it. How to integrate or differentiate sine and cosine? It's not too difficult. It is possible to draw some pictures and then to memorize or to find out how to differentiate or integrate sine and cosine. So let's just have a look. We have some nice sine here. And now when we differentiate, we tell the story about the slope, right? Differentiation means I have a function which tells me the slope of the function. And so we see the slope positive, positive, positive. Here, turning point, slope is 0, and then negative. So slope, if we want to draw a picture of the duration, then we say, okay, slope here is 0. The slope here is also 0. So we have these points. What we also know, the slope here is maximum positive, which has to be 1. So we know it starts here, 0. Then we know slope is maximum negative here, goes through here. Then what else do we know? Then 0 again, so something like this, 0 again, and here maximum positive again. So we know the derivation of sine absolutely has to look, pen doesn't work, has to look like this. And maximum negative, 0, maximum positive. And what function is this? This function, of course, is cosine. So we know if we differentiate sine, what we receive is cosine. Right? It's that easy. And now, what about if we have cosine? We need to differentiate cosine. Then actually almost the same story, just the same procedure. So we have a nice cosine. and we want to differentiate it. Then we know, okay, slope here is 0, so 0. Slope here, maximum negative. Slope here, 0. Slope here is 0 again. Slope here, maximum positive. So here. So you know, that's how it's going to look like. Okay, negative, negative, negative. So it looks something like this. It's 0, positive, and 0 again. And what does it look like? Right, it looks almost the same like sine, but turned upside down. So we know this is minus sine. And so maybe you can write it like above. So we have cosine differentiated is minus sine. So we could have just saved this minute by keeping in mind this rectangle, but if you forget the rectangle, but if you know about how to build how to differentiate, then it's also no big problem. But this is, of course, it is faster if you know the rectangle. And if someone asks you to explain it, why is that? Then you draw 2 pictures and everything is fine. So it's actually not so difficult. It's no big problem to differentiate it. But the other thing is how to integrate it. Integration is the opposite of derivation, and maybe let's just have a look at an example. So let's, for example, have function sine 2x. So now we want to integrate. How to integrate it? So we start with the capital letter F and C. The C, as you may know, is this absolute element at the end, because the thing is, when you differentiate again, when we have this, when we integrate and then we differentiate again, then the thing is that we lose all those absolute elements at the end. Without x, we lose those when we differentiate, right? Like when I differentiate 5, what do I get? 0. That's the thing. So the thing is, we don't know what has been there before we differentiated. That's why we need the C. Maybe it's not totally clear, but I can explain again in a second. So, sine, we just have to look at this square and at the rectangle, and one step backward, you just go the other way, right? So we know sine, the other way, integration is, it has to be minus cosine. So minus cosine 2x. Then we have to remember, we have something there. We should apply the chain rule, right? The chain rule. So the thing is, we have to pay attention to the inner derivation. If we would differentiate this thing, we would have some 2 before as a factor, right? But we don't have the 2 here, so we need to multiply by 1 divided by 2, and that's almost the solution. And we have to add, we should add this c, because the thing is, for example, let's say I have a parabola which looks like this. It's a function. We could call it something like capital letter F, and now we differentiate it. So this is like x to the power of 2, and we differentiate it, and what will come out? Of course, we will receive 2x, so some linear function. But the thing is, if we have the same parabola, but a little bit higher, let's say x to the power of 2 plus 2. The thing is, when you differentiate it, we will never be able to remember this plus 2, right? Because, as I said earlier, if I differentiate 2, 2 will become 0. So I'm not sure, was there a 2 before I differentiated or not? Because when there was a 0 before I differentiated, it will look exactly the same as a 2. So that's the problem. So that's why we should add the c, just to mark, okay, we don't really know what C is, but we know that there could be some C. It could also be 0, but there's a high possibility there that there was some C before, right? And when we differentiate this, we will receive this, no matter what the C is. So we should really pay attention to the C. Just write it down, maybe add something like C element R, something like this, just to pay attention, to make it correct, to say we know about it and we marked it. So this is how it works, integration of sine and cosine. Not too difficult, just remember this rectangle, and maybe, I think it's not so difficult, just remember maybe also those two pictures, just in case you forget about it. It can happen in an exam or something you forget about, or even for different purposes it might be very useful to know where this rectangle comes from. And that's about it. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.